ரொம்ப நேரம் Hi guys. Ashwik, what's your mom's email ID? Ashwik, what is your mom's email ID?
Namagada Salu.
Oh, okay. It starts with NEMMA Nelluria. No, okay, I don't have it. I'll send it to you, okay? Your mom requested for something, so I sent it to you, okay?
Okay.
You can give it to your mom.
Okay.
Any questions on the homework, guys? Any questions on the homework?
There was no homework.
Yeah, there was no homework this week.
One second, let me see. Did I forget or did I give you the alchemist one? I thought. Hold on, let me check. Maybe I am wrong.
Wait, Miss Priya, was the test the homework?
Let me quickly check. I thought I gave you. Hold on. Yeah. What ma?
I didn't get it.
No, alchemist topic was last week. Did you finish all these alchemist topics, guys? Square of a binomial, difference of squares. Did you complete?
Yeah.
Would
Yeah.
anyone like to share their alchemist page? Would anyone like to share the alchemist page? Anybody would like to share the alchemist page? Yes, no. I'm okay with anything. No, no means you have to say a no, right? Dia, how are you doing in school, ma?
Good.
What are they doing in school?
We're doing like geometric sequences and like growth and decay models.
Okay, I'll have to cover that a little bit later. It comes a little bit later, but I'm wondering whether I need to cover exponential functions. No, I'll go ahead and see. Actually, I want to finish. Did we cover completing squares, guys? Did we do completing squares?
I don't think so.
Linear programming, transformations. Okay. Quadratic formula we did, huh? Did we do quadratic formula?
Yeah.
Okay, that's see two in what I have. Okay, so functions we have done, but we have not done transfer. Okay. Okay, you need to know that as well. Your school has not started quadratic functions, right, Johan?
Yeah, not yet.
School has not started. Okay, let me give you quickly an introduction to um, imaginary numbers, and then I really want to go to geometric sequences, arithmetic sequences as well. Let's see what we can do today. Okay, let's see. See, but okay, let's see what we can do. Okay, so how about this? You know, have you heard of this square root of -1? Square root of negative numbers do not exist is what we have always said, right? So
Yeah.
square root of a negative number does not exist. That's what you know of, right? But you know, the mathematician Euler came with a big idea. Hey, let's define square root of -1 as an imaginary number. It does not exist in the real number system. When you talk about the real number system, we talk about rational numbers and irrational numbers. Make sense? We talk about rational numbers and irrational numbers. Within rational numbers, we talk about integers, whole numbers, counting numbers. Remember? In irrational numbers, we talked about square root of 2, pi, square root of 3, square root of 5, like that. So, this realm of real numbers is entirely different from imaginary numbers. Imaginary numbers only do not exist at all. So, he defined this number as I. Square root of -1, he defined it as I. Then what is I square? He did that as -1 times -1, right? Because if I is the square root of -1, I square root of -1 times square root of -1. Then I square will be equal to square root of -1 times square root of -1. So what is, so when I take square root on I square is that, then how can I call, what is I squared? I square will be
1.
-1, right? Two copies of a number bring one out. Does that make sense?
Yeah.
So I define I as an imaginary number. This number, just like we write 3, 4, 5, in real numbers we write 3, 4, 5, right? Like that, an imaginary number can be marked in an imaginary plane. Usually we draw the coordinate plane, right? So here, this is called the imaginary axis. Okay, this is called the real axis. So any imaginary number can be defined as a plus bi. This is the imaginary part, this is the real part. Make sense? Now, suppose if I have 3 plus 4i, just like this, 3, and then this is the imaginary part, right? So this is 3 plus 4i. Make sense, guys? X-axis is your real axis. Y-axis is your imaginary axis. Whatever the I value is there, right? That is on the imaginary axis. So 3 plus 4i will be somewhere here. Make sense? Any questions? Now, I also told you I is I square is a -1, right? Now I am going to make you guess certain things. What is I cube? What is I power of 4? What do you all think?
Do we have to send it to you?
You can shout out, please. Let's make it interactive. You're all new to this, I know.
-1 to the square root of 1 and
Negative?
for 3, -1 to the square root of 1.
What is it, Manish? -1?
To the square root of -1.
Why is that? Yeah, but then, yeah. But I want it in terms of I. See,
Negative 1i or I negative 1.
good job. Can I call it as negative I?
Yeah.
I power of, why is negative I? See, I cube can be written as I square times I. I is a -1 times I is a negative I. Any questions there?
No.
Now what is I power of 4? What is I
Neg-
power of 4?
1. 1.
Wouldn't that also be -1? No.
Yeah. Sorry, Ma, what was that?
1.
Wouldn't it also be -1 though?
Why would it be -1? You know, I
Or like 2 copies of -1.
two copies of negative 1, but you're going to multiply them together, right? There is no inside the square root, right?
Yeah, so when you multiply together, you'd get 1.
Yes. Okay,
Oh.
now you're going to look at a pattern and I'm going to ask you more questions. So you have to be observant here. What is I power of 5? You're going to look at the patterns coming up, okay? What is I power of 5?
I.
I. Why I power of 5 is I?
Because 1, I to the power of 1 is I, and I to the power of 4 is 1.
Exactly. I to the power of 4 is 1. I to the power of 1 is I. So I power of I is I. What is I power of 6, you think?
I.
If you say I, you have to explain to me. Huh?
-1.
-1 is correct. Why? I power of 6.
I just found a pattern because it's just like the same thing repeating.
Aha. I power of 7 is a minus I. I power of 8 is a 1. Okay. So you think you all saw the pattern now, right? What is I power of 98? A 96. Let me make it easier on you. What is I power of 96? Huh?
It's a -1.
Really? Why is a -1?
I think it's
1.
Ashwik, why do you think it's a -1?
Because I just did multiples of 8 and then there's a remainder of 2. So then I added I to the power of 2. So it'd be a -1.
There is no I power of 2, right? How did you write this? Go ahead.
Wait, one sec.
Yeah, sure. Anybody can help. Anybody can pitch in. Hmm? It's easy to say. If you have observed the pattern properly, it's easy.
Would it be 1?
1. Why?
Because 96, like it go every single for like every pattern of 4 would be I, then -1, then negative I,
Exactly.
then 1.
If the power is a multiple of 4, it's going to be 1.
Oh wait, never mind. I thought it was 98.
Now, okay, 96. Now let me ask you this. How about I power of 97?
Negative I?
I. It comes to this. Do you see it? The pattern keeps on repeating for every 4. Do you see it?
Yeah.
What is I power of 98?
-1.
-1, because it is two numbers after multiple of 4, right? 96 is a multiple of 4, 97, 98. So it comes here. You got it? How about I power of 19? Where does it come to?
-I.
Minus I, because I power of 16 is a multiple of 4, and after that you go 3. 1, 2, 3. You got it? It circles back. Any questions? Any questions? Suppose if I ask you to multiply to add two complex numbers. I'm asking you to add two complex numbers. Then I goes with I, real part go with the real part, imaginary part go with the imaginary part. Answer becomes this. Got it? Whenever I multiply 9i with the I, what happens? 9i square, which is a -9. Any questions? I square is a -1, right? Now, yeah, go ahead with this one. How about this? Suppose, let's see whether you can add, subtract, multiply, okay? How about this? What is I power of -2312? You want to check if it is a multiple of 4, see the last two digits. If it's a multiple of 4, it's a multiple of 4.
Is it like 1?
Good. It's a 1. Why? Because see, negative exponent, whatever it is, you can do it like this to make it a positive exponent. But this will be a 1, right? So it's going to be a 1. Ma, anybody has any questions on this? Anish, did you understand?
I was the one that answered the question.
Okay, let's go ahead. How about what is this, guys? You're going to, please all of you do it in chat, this one. I just want to see how many of you understood. Slowly do it, guys. It's not hard, but at the same time, please take your time and do it. It's not at all hard if you understand it. It's a simple chapter, so I thought I'll finish this. See, but this comes for you only in algebra 2. But you will have a big benefit by doing all this now. You'll have to remember and keep doing things. That's the only criteria.
Miss Priya, I sent my answer.
Where am I? What am I doing? Wait. Ashwik. Yes, Ashwik. Anish. Yes, Anish. Yes, Johan. Yes, Ritisha. I'm waiting for the others. Ashwin, did you get it? Dia, correct, ma. Can I move on? Thanks.
Wait, Priyanti, can you explain how to solve this? I don't understand.
Absolutely, no problem. I'm glad you're asking. So this is like a -1 times 9 times I, right, Vishnuram?
Yeah.
So everything is going to be square. -1 square, 9 square, I square. What happens? This becomes a 1. This becomes a 81. This becomes a -1.
One.
So answer is -81. Can I move on?
Yeah.
Okay. Now I want you to multiply this, guys. 4 plus I minus 2 plus 3I. How are you going to multiply? You know multiplication of binomials, right? Can I expect you to do this? Can I expect you to do this? Multiply those first and then you'll multiply these two next.
Yeah.
Can we try? வச்சிருப்போம். படுத்துடணும்.
Miss Priya, I sent my answer.
Me too.
Sorry guys, I'm here. Oh wow, you're all super fast. Not really, Vishnuram.
Wait, what am I supposed to do with the I then?
No, your numbers are incorrect. But the way you represented is correct. Pratisha, that's correct. The 14 and the 8 are incorrect, that's all. Johan, correct, Johan. Ashwik, correct, Ashwik. Anish, correct.
Yeah.
Vishnuram, your answer should be in that format only, that is correct. But the numbers are incorrect.
Okay.
You want to check why? Shall we check together? Dia, did you get it, ma?
I sent my answer.
You sent your answer, ma. I'll check. Sham, correct. Ashwin, correct. Dia, correct. Okay, Vishnuram, let's do it together.
Okay.
4 times -2 is -8. 4 times 3i is 12i. I times -2 is -2i. And then I times 3i is 3i squared.
Oh, I put that as I put that as 4i.
Yeah. No.
Yeah, I know. I know.
-3.
Yeah, I just put it wrong. That's why.
Did you get it now?
Yeah.
Okay. So I'll give you one more multiplication. You guys are really good. That's why I'm giving you this, okay? Fraction manipulation should be in your fingertips. You should be able to multiply fraction with a whole number, okay? This chapter is very easy provided you get the right input and quickly keep moving. Focus and keep moving. This is very easy chapter. Chapter 12, fully I want to do it today.
Miss Priya, is that my answer?
Yeah, ma. One second. Um, Shyam, correct, Shyam. Anish, not quite. Ashwik, not quite. Johan, correct. Ritisha, correct. Ashwin, I would like to get your answer too, Ashwin. Yeah, I'm checking. Ashwin, correct, Ashwin. Not quite Vishnu Ram. Guys, I'm going to do 2 by... I'm going to multiply 2 by 3 with a 3. That gives you a 2. 2 by 3, when you multiply with a 3, it gives you a 2. And then I multiply 2 by 3 with a 9. What will I get? Minus 9. So I'm getting a minus 6. You have to be very patient and correct with the fraction manipulation. Now next one, what I'm going to do? Next one, I'm going to multiply the minus 1 by 3i with 3. Minus 1 by 3 and 3, when I multiply, it's a minus I. And then minus 1 by 3 with a minus 9. If I multiply, it's going to be a plus 3. However, plus 3i square. You need to be very careful here. So 2 minus 7i minus 3. So this becomes minus 1 minus 7i. Did you guys get it?
How'd you get the minus 3?
Because 3i square is a minus 3, right?
Oh yeah. Oh, okay.
It'll come with practice. Did you get it, Dia?
So I did 18 over 3, not realizing that 18 was a multiple of 3.
I
So
saw. I saw. I saw. Can I move on? But that gives only 6i minus 2, right?
yeah, I think I did something else wrong.
Okay.
I accidentally thought it was 3. The 9 was 3.
I see. I see. How about this, guys? Okay, see this one. I'm going to give you something. You're going to be astonished. You're going to develop a pattern, please, from this one. You're going to develop a pattern. I multiplied two complex numbers. See what you're getting on this. But there is a special pattern for these two complex numbers. What is special about these two complex numbers?
Sign
You
is
know What is it, ma?
Sign split imaginary.
Yeah, so what is this? What formula you have learned?
A plus B times
Times.
minus B.
Good job. Yes. I'm so glad you're all recognizing this. I have algebra 2 kids that cannot recognize this pattern. Please, 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 if you're in this class, you should be able to recognize the patterns like this. A plus B minus B. So what is the answer to this? What is the answer to that?
25.
Oh, good job. Yeah, but what is the answer to this formula?
9 minus 16 I squared.
Exactly. 9 minus 16 I square. A square minus B square. Difference of squares.
I thought you wanted it simplified.
9 plus 16 is a 25.
Yeah.
Makes sense? But what is the special pattern and what did you end up with? You see, when they are A plus B, A minus B format, that means only if the sign of the imaginary part changes, what you end up with? You end up with only a real number. It does not have an imaginary part, right? So, A plus BI and A minus BI, they come together. A plus BI and A minus BI are called conjugates. Okay, when you multiply conjugates, you end up with only a real number. Makes sense? A plus B, see, it is the same numbers, but then negative imaginary part. Can I move on from here? I'm going to ask you this. Can I move on from here? Now I'm saying A plus BI times A plus DI. I'm saying that this is a real number. This ends up in a real number. What is the relationship between B and D? How B and D are related? How B and D are related? How B and D are related?
They both have I.
I'm saying the product is a real number.
Plus, they're like positive.
Are they the same number?
Good. They are the same number, but
Oh, they have different. Wait. No, never mind.
true.
Different
Your
size.
opposites.
They're opposites. They have to be. See, if their product is going to end up in a real number, they have to be conjugates. This is what we just discussed, right? So B has to be minus D. You got it? Okay. So that's good now. How about this? How do you rationalize this? You cannot have irrational denominators, right? You cannot have irrational numbers in your denominator when you express an answer. This is not a correct answer in mathematics. Wherever you go, you have to rationalize it. How do you rationalize this denominator? How do you rationalize this denominator?
Multiply root 2.
By square root 2.
Yeah? You make this a real part, correct? This is acceptable. You all agree with it, right? Now I'm going to give you this. How do I rationalize this? This is not even an irrational. This is an imaginary denominator. You cannot have. So how will you rationalize this?
1 plus I.
Good. Multiply by 1 plus I. It becomes real, right? If you do that, 1 minus I square in the denominator and 1 plus I in the numerator. So 1 plus I by 1 plus 1, which is 1 plus I divided by 2. Any questions? Any questions? Any questions? I can write this out as the real part is half, imaginary part is 1 by 2I. Did you guys get it?
Yeah.
Okay, so this is not a, you see, you're getting introduced to complex numbers, addition, subtraction, multiplication. You're not getting even introduced to division. Get it? Let's see. Um, okay, how about this? That's a hard one. Okay, let's try this one. I wanted to try this one though, but I don't know. Okay, how about this? This is one problem that was a little hard. Let's see. You have to think though. Find all complex numbers whose squares equals 7 minus 24i. I can give you a hint. Complex numbers should be in the format a plus bi, right? So find out a plus bi. How many a plus bi's can exist whose square is 7 minus 24i? You have to be able to expand that now.
Can I go to the bathroom?
Yeah, sure. But you have to expand it, try.
Yeah.
Mm-hmm.
Priya, can I go to the restroom?
Yeah, please, ma. Come back quickly, but I would really like to finish with this question, this one. No, you don't understand.
Wait, Miss Priya, I have a question.
Yeah, yeah.
If it's 7 minus 24i, wouldn't it be in the format like a plus b times a minus b?
But you can, Ritisha, you don't need to do anything on this side, but you can expand this, right?
Oh, yeah.
Yeah, if you expand this, and if you expand, you always get a real part, imaginary part. You can equate the real parts, you can equate the imaginary parts, right?
Yeah.
Can
Okay.
you try?
What format should the answer be in?
Format, the answer would basically be two complex numbers.
Oh, okay.
Shall I try?
Yeah.
I think I almost got it.
Okay, so I'll wait. No problem.
Okay.
Let me know, guys.
I don't understand this.
Okay, can I go ahead and do then?
Yeah.
Tisha, did you get it?
Almost. I just have to check one last thing.
Okay.
This answer I think might be too big, but
It is not a big answer, right, Amma? Yes, please.
I'm
Go, 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 go.
I just got a really big answer.
A square plus B square plus what is it? 2abi equal to 7 minus 24i. That's all, right?
Yeah.
Now, what is the real part here? What is the imaginary part here? Can I equate it to this?
But wouldn't it be negative b squared? Because you'd also square the I.
Good job. That is a find. Yes, that's so true. This will be a negative b square. So a square minus b square will be equal to a 7. 2ab will be equal to a minus 24. Am I making sense?
Yeah.
ab will be equal to a minus 12. Right? And a square minus b square will be equal to a 7. So what are the possibilities? I just expanded this. Then I equated the real parts and the imaginary parts. Real part was this, imaginary part was this. I just equated with 7 and a minus 24.
Negative 4 and 3.
Good. Negative 4 and 3 is one answer, correct? Is there any other answer?
Negative 3 and 4.
Exactly, negative 3 and 4. Those are the only two possibilities, right? Now, so my answer can be minus 4 plus 3i, or it can be minus 3 plus 4i. Those two are the possibilities. Now, we answered this question, that's true. Find all complex numbers whose square is. So if you square this number, let's find out. Are we getting it? We'll do a sanity check. Minus 4 plus 3i the whole square. 16 minus 9. This will be minus, which is 12, 27, 24i. So this makes up 7 minus 24i. Makes sense, guys? Let me check whether this answer is right. Minus 3 plus 4i the whole square. 9 minus 16. Then I have minus 2ab, right? That will be 12, 24i. So that would be what? Basically, I would have a square
Negative 7.
1 minute. Oh, this is negative 16 because of 4i square, right? And then what ma? Even as be minus 2ab, yeah? Minus, am I doing it right? I don't know what I'm doing. Let's see. Okay, so this is 4i minus 3 the whole square, right? So a square 16i square plus 9 minus 24i, right? So what would happen? Are we doing it?
You'd still get negative 7.
I still get?
Negative 7. Because I squared times 16 would be negative 16.
Are we doing it correctly, ma? Let me see, wait.
I'll break it down and check.
A plus b the whole square, a square plus b square. No, right? I take it as, okay, I take it as a plus b the whole square. So what it becomes? A square, good, b square plus b square plus 2ab means plus, okay, so it becomes minus 24i. That's interesting. No, wait. So that would be, did we do it correctly though? So the answers were 4 minus 3i, correct? 4 minus... did we do it correctly, guys? Minus 3 plus 4i. One answer was minus... that was incorrect. Why was it incorrect?
You make me
4 minus 3i. Why was it incorrect? Can I check once, please? Here, this one. Did we get the answers correctly? We had minus 4 plus 3i. Minus 4 plus 3i, correct? And then... oh my goodness. You see what I did here? I made a mistake, guys. This is a plus bi, right? See, the way I wrote it down was, it should have been a plus bi, right? So it's always minus 4 plus 3i. This I wrote it correctly here. Great. But when I wrote this down... oh my god. It should have been 4 and minus 3. You see what I mean? Okay, let's see. Okay. Let me go back a little bit. I'm glad we checked it. When we checked it, we found an error here. See, here, let's see whether our answers are correct. Minus 4 and 3, when you substituted, 16 minus 9. That is correct. This is a correct answer. Can we please put this in and check? Is that right, you all think? It's not right when you think
No,
about
you
it.
get -7, not +7.
Exactly. So what this should be?
3, -4?
3 comma negative 4. Okay, let's try that. 3 comma negative 4. Is that right? Check.
Oh, no, I'm sorry, that's not right.
That is also not correct. So what is correct? 4. Go ahead. 4 comma negative 3.
Yeah, 4,
That
-3.
works. So my second answer was incorrect. The way I wrote down was should have been 4 comma negative 3. Makes sense? So we need to be very careful. I did not look at this. I just wrote down. You got it? 4 comma negative 3. So the possible answers are this is 1, this is 1. We already verified this. Second answer, let's verify. 4 minus 3i the whole square, right? So that would be 16 minus 9 and then minus 24i, right? So that becomes 7. 7 minus 24i. See? Now, two different complex numbers when squared gives you the square, right? That means square root of this complex number, we will say square root of a complex number will be either this or this. Anytime square root of a complex number will be two answers. Does that make sense? Make sense?
Yeah,
That is one big difference, yes. Can we move on? Okay, I think this is enough on this intro is enough. But you may, how about this? Okay. You want to do a harder one or I don't know. Do you want to try this? How about this? Do you think you can simplify this? I don't have the answer to this. Let's see. Can you simplify this? We are going to work together. I don't have an answer to this. Let's see. Can you do that for me? What is that? I don't know what is that. You want me to do that? I can do that. You can remove negative exponents by flipping.
Miss Priya, I sent my answer, but I'm not sure about it.
Okay, I don't have an answer, ma. I can check myself by working it out.
Okay.
If that's okay with you.
Yeah, I worked it out, but I don't know if all my parts are correct, like my flips.
I feel there is a denominator, but I don't know. I'll have to work it out and see. Can I work it out as well, or somebody wants me to wait? I'll wait.
Kind of confused on this.
I can try solving you.
Okay, you solve. Okay. Sure, I'll wait. Ashwin, that's what you said, right, Ashwin?
Yeah.
Sure, sure. I'll wait. Let's see.
Is that right?
Ashwin gave a. Not really, Ashwik. Where is the real part? I feel like there will be some real part as well. Oh, Sham also got the same thing. I don't know. Let me work it
Because
out.
I got negative I over 2.
Yeah. That's what Sham also has said, but I am thinking there has to be a real part. Can I check? So,
Okay.
That's my answer.
I'll check you, Han. I don't
Because
know. Okay, let's see.
what I did is I did I to the power of minus 1 is I a 1 by I, and then which is negative I.
Yeah, we'll check. Come on. 1 minute, Ashwik. Johan, you cannot have a complex denominator. Did you remember that?
Oh, yeah.
Okay, so this one I can write it completely as this. Can I write it like this? I am thinking, yes, I can. To remove my negative exponent, yes. Now, this again I can simplify that as this, right? Now, when I take LCM in the denominator, so it becomes I, one can be written as I by I, right? Fraction, right? I minus 1 by I. Now, fraction division, flipping it, I'll get I by I minus 1, but I cannot have a complex denominator, so I'll multiply by its conjugate. That becomes I square plus I divided by I square minus 1. That will be minus 1 plus I divided by minus 2. So that, again I don't want a minus in the denominator, right? Take it up, so that becomes I minus 1 by 2. Did you guys get it?
I kind of did it in a different way because I didn't have so like what I did is I did I to the power of minus 1 is 1 by I, which is negative I.
Wait, ma. I to the power of negative 1 is 1 by I, okay?
Which is negative I. And so I minus like negative I is 2I. And then
What is 2i? Wait. What is 2i?
So then I did I minus negative I.
Where is I minus negative I? This is I minus 1 by I, right?
Didn't she just like
Because like
No, you
no,
can
it says
explain, Ashwin. I'm just asking you, huh?
so I like I minus I to the power of negative I is negative I.
Where, ma? I didn't get you. Can you show me on the board? I don't see what you're saying.
Okay. Let me try empty. Okay, so this value is negative I,
Okay.
and so
That's what I expanded, right?
yeah, and then I did this and I got 2I.
You cannot get a 2i. How can you get a 2i?
Because like I figured out for this equation, so I minus negative 1, which is negative I.
Ashwik, what did you process first?
So first I did I did PEMDAS, right? So I did I to the power of negative I.
Where is I power of negative I? Illa, Ashwik, somewhere I am losing track of what you are saying. Okay, let's try one more time. I'm going to delete your drawings.
Okay.
Can you explain what you did? Please
Because
write down
it's
step
1
by
by
step.
I
No,
equals
no.
to
Step by step, go ahead and write down here.
Okay.
Write down, let me see.
Okay.
Meaning somewhere I'm missing your track. So can you go ahead and do it for me and I'll check.
Hold up. I'm gonna try to annotate.
Yeah, you do. You annotate.
But there's no annotation option for me.
Okay, so what should I write as the next step? Tell me.
Okay, so what I did is I did I to the power of negative I.
Where I to the power of negative I never gave you. This is a -1, right?
I mean, yeah, I to the power of negative 1, my bad. And
Okay.
then after that, so I did I got 1 over I.
No, what happened to this?
Yeah, that was 1 over I.
But you cannot take this like this, right?
Yeah, I know. I
Then,
did
then how come it became I power of -1?
I was talking about
See
this.
here, 2 minus 3 power of -2 minus 3 power of -1 can't become 2 power of -1 minus 3 power of -1. You cannot bring powers like that unless it is multiplication here.
Yeah.
You got it, huh?
Okay, yeah, I got it.
So that was a mistake, I feel. You see, what else did you do?
So then after I did like inside the parentheses, I did I to the power of negative 1, and then I got
Did you do this?
yeah
But then this power of -1?
is yeah.
No, yeah. So this is the mistake. There is subtraction here. If it was like this, yes, I accept. You can bring the power inside, but there is a subtraction. You cannot bring the power like that. You got it?
Yeah.
Okay, can I move on?
Yeah.
Okay, I'm glad you're discussing Ashwik these. Okay, now I know these are okay. So we need to study parabolas. We need to study completing squares. In the meantime, I want you to understand a couple of things. We discussed function composition, right, guys? F of g of x. Did we do that?
I think so.
Yeah, we fed the output of one function as the input to the other function. That we did, but I did not cover inverses for you. I really want to finish that one thing. Okay. Inverses, let me give you a brief description of function inverses. The concept is easy. They are just introducing you. They are not going in detail, but it is so helpful if you know this when you go to Algebra 2. Let's see. Now, suppose a function is given as this. Okay. Inverse of that function is written as this. Please understand, this f inverse is not equal to 1 by, this is not a reciprocal. Inverse is not a reciprocal. This is the biggest mistake people do, is not the reciprocal function. We have, how many functions you've learned? You have learned a lot of functions, right? Multiplication, division, addition, subtraction, reciprocal, so many things you have learned. Next thing what we are going to learn is, what is the inverse operation of a function? It is denoted using the symbol, but it is not the reciprocal operation. Okay, I'll tell you what it is. Let's say a function f of x is given by, these are bit concepts that are really useful for Algebra 2. You would not study in Algebra 1 at school, okay? But our promise is, our goal is to complete the book, so I really want you to get introduced to these concepts before you get to Algebra 2. Now, how to find the inverse? These are the clear steps. I'll tell you, first let me tell you algebraically. We are going to do algebraically without knowing what is the function at all. What is the function inverse? We are going to, I'll tell you the steps, I'll tell you how to do it algebraically. Then when I show it to you in the graph, everything will make sense. Till then, nothing will make sense. It's like it's like we are just following steps. Now, I can write this function as y equal to 3 minus 2x. Second step, switch x and y. Okay, x will be equal to y minus, 3 minus 2y. Any questions still here? Then this is not a step, right? Okay, first step was write f of x as y. Second step was switch x and y. Okay, so the third step is find y in terms of x, and that is the inverse function. That's all. Now how do you find out the y? X minus 3 divided by minus 2 equal to y. You can write this down as 3 minus x by 2. So this is the y, right? That is the f inverse function, will be equal to 3 minus x by 2. Any questions? Very easy. You wrote f of x as y, and after that you switched x and y, right? And after that you found out y, you brought this to the format y equal to. You wrote that as the inverse function. Any questions? Any questions? Any questions there? Okay, how about
What's
can you
the homework?
let me finish this, ma. 2x minus 9. Can you find out the inverse function of this algebraically, methodically, following the same thing? I'll also show the graph, so everything will make sense a little bit.
I answered.
X plus 9 all over 4. Is that so? Let me check. I don't want that pings here in the class. Sorry, guys. Correct. Correct. Yes, correct. Correct, Johan. So you got it. So what is this function, guys? Let me show you the graph. Okay. Let me show you the graph of 3 minus 2x. I'm going to draw the graph of 3 minus 2x. I'm not going to go to this. This is just for your checking. Okay. 3 minus
Miss
2.
Priya, can you check my answer?
Yeah, ma, I can. Correct, Shyam, that's right. Ritisha. Minus 2 should not be in the denominator, right, Ritisha? Minus, you have to take out the negative of the denominator, right?
Oh, okay.
Vishnu Ram, that is correct. Okay, now let me draw the graph and show you quick, guys. Okay, 1, 2, 3. I'm just graphing the line. I'm going back to our basics. Okay, I just want you to understand what is an inverse function. 2, 3, 4. Now this is 1, 2, 3, 4. So I'm going to pick out 2 points. I have to pick out, right? What are those points? 0, 3. And then if I put this 0 here, 0, 3 is a point. Okay, that is 1 point, and the next point would be, let's say I put a 0 here. 3 will be equal to 2x. X will be equal to 1.5. 1.5 comma 0 looks like. So that is this line. Okay, this is my f of x line. Any questions? Now I'm going to draw this line, f inverse of x. So what does it say? That gives me minus 1 by 2x plus 3 by 2. That will be equal to the inverse function. If I plot the inverse function, right, I get 0, 3 by 2, 0, 1.5. And then the other point, what do? I put a 0 here. Then minus 1 by 2, x equal to minus 3 by 2. So x will be equal to 3. 3, 0. Do you see what happened, guys? What happened? Something happened. This was 3, 0. this was, okay, this was 3 comma 0 1 0 comma 3. Oh, sorry, this, let me write it in black color so that you clearly get it. The main function, I had 2 points, 0 comma 3. The second point was 3 by 2 comma 0. Okay, now when I plotted the inverse function, something happened. It became 3 comma 0 and this became 0 comma 3 by 2. What is going on? What is the relationship between a function and its inverse? What is the relationship between a function and its inverse? What do you think?
X value and Y value switch.
Wow, yes. So the domain of my function becomes the range of my inverse function. The range of the inverse function becomes the domain of the main function. Make sense? That's a big learning. Okay. And when I talk about graphs, right, what is this line? What is this line? What is the equation of that line? Dotted line. What is the equation of the dotted line? What is the equation of the dotted line?
Y equals X.
Y equal to X. So now let's start from my main function. My main function is this, okay? I treat my dotted line as a mirror. I treat my dotted line as a mirror, okay? So this part of my original line, I try to mirror it. Mirror it in the sense I try to reflect it on that Y equal to X line. When I mirror it on that X equal to Y line, the top part becomes this part. Now there is another part of the line that I did not do. Which one? This bottom part. I did not reflect it. How to reflect the bottom part? On where am I reflecting? My mirror is the Y equal to X line. You see, this is my mirror. You got it, guys? So basically, when I reflect the f of x on Y equal to X line, I get my f inverse of x. Graphically, whatever function it is, let's say they give this function. Okay, what is the inverse function? How to find my inverse function? Let me take this off. If I'm given a parabola, right, they ask you, hey, what is the inverse function? It's not hard. Immediately draw this line. Okay, but I can't reflect this. Okay, I'm not that I don't have that much of a brain to reflect it on this line. So you know what I do? I break it piece by piece. Okay, this piece, let me reflect it on this line. You see? And then this piece, let me reflect it on the same line. It will become this. So I have achieved only bits and pieces I have achieved. This one is the reflection of the black line. Now I split it into part by part, so it's easy for me. How to reflect this line? Reflecting this line is easy. This is the function. So which is f of x? My parabola is f of x. This parabola is f inverse of x. Make sense, guys? I take this dotted line as my mirror. Okay, whatever function, whatever graph I'm given, I split into piece by piece. This gets reflected here. Again, this is the second part of the function gets reflected here. Then the third part of the function gets reflected here. So my reflected function is all about this. Make sense? Does it make sense? Guys, yes, no, please tell me. So
Yeah.
f inverse of x is a reflection of whatever function it is, f of x on line y equal to x. That's the conclusion when graphing. Does it make sense? Now, one last thing, okay? F inverse of x, if you found out your inverse correctly, then the composition of a function and its inverse is always equal to x. That means composition of, I'll show you what it is and then let you go. Composition of a function and its inverse is always equal to x. Then only the inverse function exists. F inverse of f of x is equal to x. Both can be written. Both are the same basically. What does it mean? I'll show you what it means. You don't have to do. F of x is 2x minus 9. You all found the inverse of this as x plus 9 by 2. Correct, guys? Now, I'm going to feed this as my input to my original function. Instead of x, I'm going to substitute f inverse of x. Wherever I see x, I'm going to substitute f inverse of x 2 times. I saw x here, so I'm going to plug in this value. X plus 9 by 2 minus 9. What I'm getting, check. 2 and 2 get cancelled. X plus 9 minus 9. See, f of f inverse of x equal to x. Always. Got it? This means I'm feeding f inverse of x as the input to my original function. This means I am feeding f of x, what? The original function, as my input to the inverse function. That means this 2x minus 9 I am going to substitute here. 2x minus 9 plus 9 divided by 2. See what we are getting? Again x. So there are some basic concepts we learnt. What did we learn? What is an inverse of a function? Algebraically you found. And then graphically, it's just a mirror reflection of any given function on the line y equal to x you learnt. And then the last part that you learnt was f inverse of f of x will be equal to x, or f of the composition of a function and its inverse is always equal to x. That intro part is enough. So for the homework, you're going to do 16.4. 16.4 you'll do, and then you're going to do chapter 12, and we'll see you after the break, I think, from now, right? Okay,
Yeah, I
guys,
think so.
enjoy the break. Happy Christmas, happy holidays to all of you. I'll circulate the calendar shortly. Okay, and also we have to arrive at when we are going to, how many of you want to continue AOPS geometry or ordinary geometry? What do you want to do? Get me some inputs now. I asked you to ask and come, right?
I don't mind like either. I don't think my mom does either.
Okay, how about Vishnu Ram?
My mom said anything's fine.
Ashwik, how about you? Oh, yeah, Ashwik, I think I discussed with your mom. What was your mom's thought?
I don't think I heard it from her yet. I'll ask her.
Okay, you'll ask her. Ashwin, any thoughts? Oh, Ashwin, yeah, I know your mom. You're discussing on CB and stuff. Okay, I'll wait. I'm not going to push you. Diya, how about you, ma?
I didn't get to ask her yet.
Okay, Johan, I know what you're doing. You're already doing geometry, right? So leave it. Shyam, how about you?
I have to ask my mom.
Okay, no problem. You're going to ask and let me know. Make sense? Okay, guys. See you all. Bye. I took too much of your time. Have a nice break. Enjoy the break. Come back with full force.
Okay.
Okay, bye, Auntie.
Bye.
Alright, bye.
Bye now.